In this video, I will be going over 13.1 exponential growth functions, and I'll be going over Explore 1, which is on page 635. So an exponential function is a function of the form f of x equals b to the x, where b is the base, is a positive constant other than 1, and the exponent x is a variable. Notice that there is no single parent exponential function because each choice of the base, b, determines a different function. So if b was 2, it would be 2 to the x. If b was 3, it'd be 3 to the x. If there was 4, it'd be 4 to the x. So that's why there's no parent function. But we're going to look at two different exponential growth functions and see what these look like. So we're going to take x, which is -3, and plug it in here. And remember that negative exponent moves to the bottom, and so I get 1 over 2 to the third power, which is 1 over 8. And then if I plug in 2, I get 1 over 2 squared, which is 1/4. If I plug in -1, I get 1 over 2, which is 1/2. If I plug in 0, anything to the 0th power is always 1. If I plug in 1, I get 2. If I plug in 2, 2 squared is 4, and 3 cubed is 8. So now let's do that for 10. So if I plug in a -3, I'm going to get 1 over 10 cubed, so 1 over 1,000. If I plug in 2, I get 1 over 10 squared. Sorry, if I plug in -2, that brings it to the bottom, and I get 1 over 10 squared, which is 1 over 100. A -1 brings it to the bottom, and I get 1 over 10. 0 is 1, and 1 is 10. 2, so 10 squared is 100, and 10 cubed is 1,000. So those are the values for f of x equals 2 to the x, and p of x equals 10 to the x. So just remember that f of x and p of x are just y, or y equals this. And so we're going to plot this. Let me zoom out just a little so we can see all our values and still graph. There we go. So on this one, we're going to do y equals 2 to the x. And so my first point is -3 and 1/8. So -3, if this is 1, 1/8 is like almost, oh, I'm going to have to zoom in a little bit for this. 1/8 is like here. Okay, the next value was -2 and 1/4. So -2 and 1/4 should be just a little higher than an 1/8. -1 was a half. So at -1 we should be halfway. At 0 we had 1, so 0, 1. There we go. At 1 we have 2. 2 we have 4, and 4 we have 8. So if we connect these, will it ever be negative? Is there any number you can plug in for x that would make this negative? No, because even if you plugged in a negative number like we saw, we still get a positive number, we just get a fraction, right? So this is going to get really close to 0, but not quite to 0. And then it's going to grow very rapidly, hence why it's called exponential growth. So if we look at this t-chart for 10 to the x, let's -3 and 1/1000th. Oh, that's going to be a hard one to graph. Let's see. -3 and 1/1000th. And let's see, -2 was 1/100th. Again, not very accurate, but I know that it needs to be slightly above 1/1000th. And then 1/10 for -1. And at 0 we had 1. What was 2? I'm sorry, what was 1? At 1 we were at 10, so at 1 I should be up here somewhere. 2, yeah, there's no way I'm going to get to 100 there. So let's see, we're way down here. And we shoot on up. Sorry for my not straight lines. But there are 2 examples of exponential growth. So it's growing slower at the beginning here, and then it rapidly shoots up. That's why it's exponential growth, because it's growing. So if we move on to the next page, 636, says, what is the domain for each function? So if you remember, my graph looks something like this, and my x values go from, well, this is going to be negative infinity all the way to positive infinity. So from negative infinity to positive infinity, and x is going to be somewhere in between those, right? And the domain for my other one, same, right? It still was here to here, and so we had negative infinity with x in between. And then what's the range? So with both of my functions that we just drew, remember it got really close to 0, but not quite at 0. So I'm at 0, x is in between, and then it shoots up to infinity for both of these. What is the y-intercept for each function? So let's actually go back and look at my t-charts that we have. So when x is 0, what was y for both of these? 1. So let's go fill that in. So my y-intercept is 1, because when I plug in 0, I get 1. When I plug in 0, I get 1. And it says, what is the trend of each function in both f of x equals 2 to the x and p of x equals 10 to the x? As the value of x increases, the value of y increases or decreases? Well, y is getting increased. Now, will the domain be the same for every exponential function, y or y not? Well, I'm going to let you guys answer that. Look at your graphs, look at kind of what we've done, and you tell me that. And then it says, will the range be the same for every exponential function in this form, where b is positive constant, y or y not? So go ahead and answer these 2 reflex.